Today we are going to discuss about a new topic, potentiometer. It is a very important instrument which is used for measuring the potential, generally EMF of comparing the EMF of two cells and for measuring internal resistance of a cell. It is a very important instrument. Generally, it looks like same as what your Western bridge. But as we know that Western bridge is made up of what? Of a wire of 1 meter. But this potentiometer is made up of 10 meter wire. How many wire? 10 meter wire is there, and as the 10 meter wire is very uncomfortable to take in a 10 meter wire instrument is uncomfortable to take in the laboratory and for our practical purposes. So what we do, we cut this 10 meter wire each into 1 meter, each having that one length of 1 meter into 10 pieces. So potentiometer wire generally consists of wire of 10 meter, and each of the wire have the cutted in a length of 1 meter, and they are connected internally with each other. Now, what is the use? We know that use of the potentiometer to measure the internal resistance of a cell as well as to what? As well as to compare the EMF of two cells. Why potentiometer? Not that voltmeter. Generally, we know that whenever current passes through a conductor, there is a production of what? Resistance and everything. Is it? Resistance is there. But when you take a cell, what will happen? In the cell, there are two electrodes are there. That two electrodes, the potential difference between two electrodes, potential difference between these two electrodes is known as EMF. And if you connect these two electrodes with the wire, then what will happen? They will give you there will be in the wire, there will be the resistance, and you cannot get the exact value of EMF. So how we can measure it? So there is a principle known as principle of potentiometer. By using that principle of potentiometer, we can go further for the measurement of EMF, exactly, comparing of EMF. What is that principle? Principle of Western meter bridge. It states that, what does it state? It states that the potential difference across any cross section of a wire is directly proportional to the length of the wire. That means EMF is there. If the EMF is there, it is also proportional to length of the wire. If the potential difference is there, it is also proportional to length of the wire. That means whatever be the length, if the length is increased, it is found that potential gradient will increase. That means we know some theoretical knowledge about it. We have to know some theoretical knowledge how it is working. Let's come to the main theory. You know, we have, if this is the potential difference across any length of a conductor, if this is the potential difference across any cross section of a conductor, then what will happen? V equal to IR. It is known from where? From the Ohm's law. And again we know R equal to how much? Rho L by A. Where rho is the resistivity, L is the length of the wire, A is the area of cross section of the wire. Then if we put the value of R, we can get what? We can get V is equal to what? I rho L by A. What if the length and area is constant, and it is found that if somehow we can manage that rho is constant, then V is equal to some constant into Y. That means V directly proportional to Y. V directly proportional to, if V directly proportional to L, then what will happen? If V directly proportional to, if we manage somehow that current is constant, if I manage somehow the current is constant, area is constant, resistivity is constant, then it is found that V directly proportional to constant into L. So we can say that V directly proportional to L. From there what we can say? We can say that Potential difference across any cross section of a wire is directly proportional to the length of the wire. Now, practically when you go for the diagram, you have to draw it like this. This arrow means that up to this much, from A to B, how many lengths are there? How many? What is the length of the wire? It will be how many? 10 meter, and it is drawn in a systematic way. This is the potentiometer, and this is the what? This is the meter scale which give you the value of what? Balancing lamp. This person is connected to the negative terminals of emitter, and this positive terminal, the emitter is connected to the positive terminal of the cell. And there is a rheostat is there, so rheostat a key is there. What we do? We balance the amount of current, constant amount of current. We have said that we have to give what constant amount of current, so that the length will be directly proportional to potential difference. So for sending the constant amount of current, we have what? We have connected it to the rheostat to balance the amount of current to flow through it. So this is the simple diagram of what? Potentiometer circuit. Okay. Now, if we want to find out the EMF of the two cells, then what we will have to do? What we have to do? We have to connect again. We have to take that potentiometer wire. We have to take the potentiometer instrument in such a way that in the beginning it is connected with what? When you want to measure the EMF of two cells, what you have to do? You have to take the keys here connected with rheostat. Okay, this key is connected to rheostat. A cell is there, suppose its name is E, its positive terminal is connected with the what? Positive terminal, the emitter, again what? It is connected with and this end, suppose this end is X, this end is Y. If you say, now, this connection is general connection of the potentiometer. That means that it will give the constant potential difference to the what? Potentiometer. Now, what we will do? We will connect this portion with this cell having EMF E1, and the negative terminal through the galvanometer we will connect it with the we will connect it to the jockey. Suppose there is jockey, here is resistance is G, galvanometer having the resistance G is there. Now you move the wire on the jockey. When you move, you move the jockey on the wire. Sorry, you move the jockey on the wire. You will find that suppose at length L1, it is giving the balance. It is giving the zero deflection to the galvanometer. When it gives zero deflection to the galvanometer, we can say that it is balanced. Is it clear? It means that E1 is balanced by this E. So we can say that by using the principle of potentiometer, we can say that E1 is equal to some constant K into L1, where K can be considered a resistance parameter length of the wire. That means what? E is equal to K into L1. Now what we will do next time? We will disconnect this one. We will disconnect this E1 from the with the galvanometer. Now we will connect this one with the cell having EMF E2. Again we will move the wire on the jockey on the wire, and we will find that it is giving zero deflection. When we connected with E2, it is giving the zero deflection at length L2. So here we can say E equal to K into L2. Now we have an equation of E1 is equal to K into L1, E2 is equal to K into L2. So we can say that E1 by E2 is equal to K into L1 divided by K into L2. So if we cancel this one, we will get what? L1 by L2. And we can easily measure the L1 by L2 by this scale. So if we know the value of L1, if we know the value of L2, then what we can do? We can compare the EMF of two cells. So this is how we can compare the EMF of two cells by using the potentiometer. Clear or not? I think this is clear. Let us come to the next topic to measure the internal resistance of a cell. Same diagram. We have taken this one as but a potentiometer, and this side is connected to the rheostat. Another cell having EMF is E there. Here positive terminal connected to the positive terminal E, and negative terminal with another end, suppose X and Y is there. And here we can say this is giving a constant amount of current by what? Adjusting the rheostat, value of rheostat. Now you see what is there, what we can have to do. We have to connect first this with a cell having E. And a galvanometer is there. Suppose the galvanometer has the resistance G. We have connected this one. Is it clear? Now, when you move the wire on the when you move the jockey on the potentiometer wire, you will see that suppose that length L1, again it is giving 0 deflection. So we can say that the EMF is how much? E equal to K into L1. And we can measure the L1 by the scale here. Now, what we will do? We will connect this one, this side with a resistance, external resistance, is it clear? And this key is on. Now, again when you move the jockey on the wire, you will find that this galvanometer is giving deflection another lamp at L2. Now, this EMF will not remain as EMF because as it is drawing, as this resistance is drawing some current, so we can say that it gives you the potential difference, not the EMF. Was it clear? So we can say that V is equal to how much? K into L2. Now again, if E by V is equal to how much? K into L1 is divided by what? K into L2, K will cancel out. And we will get what? E by V is equal to L1 by L2. We will get E by V is equal to L1 by L2. Clear? Now, if smaller is the internal resistance of the cell, then what is the value of smaller? Smaller equal to E by V minus 1 into capital R. So we can write R is equal to what we can put? E by V is equal to L1 by L2. L1 by L2 minus 1 into R. Known value R, value of R will be known to you. And by measuring this L1 and L2, we can measure the internal resistance of this cell. So this is about your potentiometer. Is it clear? And potentiometer, we can say it is very advanced in instrument. It is what? It has various useful are there, because why? Here we can say that there is no loss of what? Current due to resistance on. It gives maximum accurate measurement of the EMF as well as the internal resistance of the cell. Okay, thank you.